Okay, 10.3, Lesson 1, Part 2. Here we go with drawing these various structures. You can see we have 5 examples from pentan 1-ol down to 3,4-dimethylphene 1-ol. Okay, so we've got that. Let's draw these ones out. There's the pentan 1-ol. You can see that we have a 5-carbon straight chain molecule with a hydroxyl group at carbon 1. Okay, so if I'm going to draw that one, I might do a line angle diagram here. There's carbon 1, 2, 3, 4, 5, and then I need a hydroxyl group at carbon 1, so I can zigzag one more time, but I'll write this one as an OH. So these terminus, when we now have functional groups that involve different elements, remember in the line angle diagram, we write down anything that's not carbon and hydrogen. So the carbons are the ones without any notation. This one here is the oxygen. Okay, we can take a look at 4-methyl cyclohexane 1-ol. Again, remember, it makes most sense to look at it from the right and then take a look at your branches. So I see cyclohexane here. So I will make my hexagonal structure. Okay, all single bonded. And anything can be carbon 1. So if this is carbon 1 right here, there's my OH group. And then I have a methyl group at carbon 4. So carbon 1, 2, 3, 4. 1, 2, 3, 4. Doesn't matter which way I go on that one. There I have my CH3 grouping. Next one we have is 5-chlorohexane 1-ol. So again, hexane, so we have another 6-carbon chain here, very similar to this one, but you'll notice no cyclo prefix in the name, so it is a straight chain molecule. So I will do my 6 carbons, 1, 2, 3, 4, 5, 6. There's the hydroxyl group making this carbon 1. It's a 1, 2, 3, 4, 5. I need a chloro group right there. Okay, so there's your 5-chlorohexane 1-ol. Here I have a diol, propane 1,2-diol. So again, as I look at this name, I can see it's propanes, which is a 3-carbon chain. And so there's 1, 2, 3. And then at carbon 1, I'll make it on the right again. There's an OH group, and at carbon 2, another OH group. So there's your propane 1,2-diol. Last one we'll look at here is 3,4-dimethylphenol. Phenol is the name that we give alcoholic benzene rings. And so we'll look at that one. Draw your benzene ring. All right, here we are with the delocalized structure with that circle in the middle. At carbon 1, if I make this carbon 1, there's my hydroxyl group. And then I have 2 more methyl groups at carbon 3 and 4. I'll go clockwise here. If this is 1, 2, 3, I need, oops, I don't even need to draw that, pardon me. I can put my methyl group in there, and then another one here. Okay. That reminds me I should probably go back and change this. Sometimes we'll see the hybridized versions putting in the CH3 grouping to help identify branches, but in a line angle, that is redundant because the carbon and hydrogens are already assumed with the line. Okay, I will show you guys another drawing for 3,4-dimethylphenol. Remember that a lot of our software online uses the resonance structure rather than the delocalized, so I just want to make sure you guys are recognizing that. And so we would have the 3 double bonds shown at one point in there, and then you would still have the other lines for your methyl groups and your hydroxyl. Okay, these lines could also be in the other spots, like here as well. It doesn't really matter. Okay, so both of those would be acceptable drawings for the phenol molecule. All right, benzene can be drawn either of those 2 ways. Okay, that brings us to the end of lesson 1 for 10.3. Please read pages 425 to 430 in the textbook. Try your nomenclature and naming practice. This is important. Make sure that you're comfortable with it, and especially some of the spelling. All right, dropping that vowel when you have alkanes or alkenes is really important. Okay, and you will see that reflected in the written response and short answer sections of your online test. Pages 430, 5 to 11, 13, and 14 all have good naming practice, and of course there is extra practice in the worksheets on D2L. Okay, lesson 2, we'll take a look at the reactions involved in the preparation of alcohols, and we'll take a look at some different types of elimination reactions to go along with the addition and substitution we've already done.